So let's talk about water quality. Water quality is one of those things that's not well understood, I suppose. It always seems like a voodoo or magic to a lot of people. It really isn't. I get a lot of calls. In fact, I got one call this week, and the guy said, well, I just moved into this pond west of Fort Worth somewhere. He said one of 3 or 4 owners of the pond, there's 20 acres or so, everybody had a lot around it. He said, are the fish good to eat? Why wouldn't they be? You know, I mean, I'm amazed at how people worry about that somehow we've polluted so much of the earth that nothing's fit to eat anymore. And unless you have a real reason to believe that your pond has been polluted by something that's right above it in the watershed, chances are about 99.99999% that everything's fine. And you should eat those fish. Anyway, it comes down to a water quality question. They think that they're contaminated for some reason. So let's talk about water quality. Well, first, some general things about water. I'll just run them up here. Water is the most abundant compound on the earth. You know, it's a liquid at most earth temperatures. Of course, it becomes a solid and a gas too. It has a bipolar structure, which is what makes it really unique, makes it dissolve things very well. We call it the universal solvent for that reason. It dissolves salts and all kinds of things. And also, because of that polar structure, it has surface tension, and that's why little insects like the water striders and everything can walk across it, why we have plants able to pull it up through the root system. It has a very high specific heat, and that's what's important as far as this whole temperature thing with our cold-blooded creatures like our fish in there. High specific heat means that it takes a lot of energy to either warm it up, or when it cools down, it's losing a lot of energy. Exactly 1 calorie per gram is 1 degree centigrade. So what that means, in just real simple terms, is water heats up and cools down very, very slowly. Because it has to absorb a lot of heat, it has to release a lot of heat to do one of those two things. That's why we may get, this morning we were 53 or something, this afternoon we'll be 82, and yet that pond's going to sit there if it is at 70, and maybe it'll go to 70.5. And tonight it'll drop back to 70. The water changes temperatures very, very, very slowly under normal conditions. And that's important because I don't know if you've ever done much fish stocking, but if you take fish out of cold water from a hauling tank and you drop them into your 80-degree pond water, you can kill them. They can't take that kind of temperature shock. So again, the fact that water is very slow to heat up and cool down affects these fish's lives because it is tolerant of what they have to survive. Okay? Why ice freezes on the surface rather than the bottom of the pond. Water is most dense. That's 39 degrees Fahrenheit if you need to think in Fahrenheit. Here we seldom get water very much that cold. But I mean, if you get ice on your pond, if you drop down towards the bottom of the pond and put a thermometer in there, it'll be at 39 degrees. It freezes at the top and at the bottom. Everybody should know the hydrologic cycle. I just put it up there to remind you that that's what's going on, that water is constantly replenishing, and there's not any new water being made, there's not any being really lost, and so the water that's in the you and I were in a fish at one point, and we're in dinosaurs at one point. It was in the ocean at one point. It all recycles back. So water is the fluid of life. Okay, so what is water quality? Well, quality is a relative term. It's suitable for a specific purpose. The quality of water we need to cool down a steel mill is not the same quality of water we need for a fish. So you've got to ask yourself, what are we talking about here? And the quality of water we need for a fish is not the quality of water you and I need to drink. Okay? So, it's suitable for a certain purpose. In this case, we're talking about fish ponds. And so usually what we do is run tests to look at what the quality of this water is. It's a matter of chemistry. We're looking at chemistry. And then see if it's suitable for that specific purpose. Water in ponds is affected by the physical nature of the landscape, a lot of chemical reactions, and also the biological reactions. And it's all variable. So it's really again, it's one of these things that seems like voodoo a little bit, but it's not once you understand some of the basic concepts for it. And again, many people think the pond is contaminated, but you really need to ask yourself, why would you even consider that? You know, unless you know there's some real problem in the pond directly or in the watershed right around the pond, there's probably no reason for it to be contaminated. Okay. Again, when it comes to fish, these are some of the things we look at normally. Again, I'm talking about temperature. I'll throw that up again. pH, everybody's heard of pH. Alkalinity, hardness, dissolved oxygen. This is the one that we'll talk about quite a bit because that's where we have problems. And we have problems with dissolved oxygen getting low enough, it literally kills fish. Most of our fish kills are caused by low oxygen. But also low oxygen stresses these animals. If it doesn't get low enough to kill them, it stresses them. And the stress is something that slows down then their growth, because if you're stressed, you don't feel like eating. And so it can make a real difference there. We'll probably talk about carbon dioxide, just a little bit about ammonia, and a little bit about some of the other pollutants. Okay, we saw this before this one, at least I've got the temperatures down here. This is roughly a bass or a catfish. Again, there's a lower lethal temperature and an upper lethal temperature. And the upper lethal is only about the mid to upper 90s. And everybody looks at that and thinks, wait a second, we get 110 last summer. How come everything didn't die? Again, water wasn't 110. Water may have only been 90. So that's why we don't see that happen very much. Again, spawning temperature and all that stuff. But again, this is labeled over here as growth per day. What this is experimentation where we put these animals in aquaria and we offer them feed every day. And we record how fast they're growing. Well, how fast they're growing is how fast they're eating. So in a way, this is a consumption curve. How much they want to eat. But what people don't understand is at this point it starts to fall and they say, well, wait a second, at 80 degrees, a bass eats like crazy. You're right. But up there around 85 or so, wherever this is, I'm looking at it from the side, they eat like crazy, but now they're so warm they can't slow down. They're on a treadmill. Their heart is beating faster. They're having to breathe faster. And so, yes, they're eating as much as they can eat, but how much can they grow? It's reduced because their metabolism is too high. Okay? Maybe that makes sense. Anyway, one of the things we always suggest people do when they build a new pond or they have a well that they want to run into a pond is get some water tested. And most people don't have the kits and all that stuff to test it themselves. So most universities or even private labs offer water testing for these things. In Texas A&M, we do. It's part of our soil and water crop sciences department, and they take soil samples or mud samples in the case of a pond or water samples, and they will run water tests for you. And this is just the what the sheet looks like, and you put on here that it's private or public, that it's well, pond, lake, whatever, maybe what you might use it for. And you send that in with a check for $25, I think it went up to, and a water sample, and they'll run these tests for you. Depending on how much you want, there's 3 different levels. But anyway, this is kind of what you get back. And again, some of the stuff we've talked about, some of it we haven't, but here's pH, here's hardness and alkalinity, salts. This one was run even on some of the metals, so you have arsenic and things like that in here. Up here you have sodium and calcium and all this stuff. And here's all the numbers. Some of the stuff is actual chemistry run, some of it's calculated based on previous tests that they've run up here. Notice here, report sent to Extension Fisheries Specialist Dr. Michael Masser, and my phone number and my email. So if you do this and mark it as a pond, I will get a copy. I get about 5 or 6 of these a day. I do not call you. But if you call me, we'll discuss it. And I'll tell you what I see. And I'm going to come back to these in a minute. But again, you can cut it off right here and not have the heavy metals done. It costs more to have the metals done. Or if you're really concerned about something like, you can go down here and pay a little more. Anyway, we'll come back to that.
What's that sample PV?
About a pint. Okay, so what affects water quality? We talked about some of this. Obviously, rain and whether some other water source is used, what's the beginning water that enters that pond like? Is it rainwater off the watershed of that pond? Is it well water? All of that makes a difference, and what's in that watershed makes a tremendous difference. The area, we try to design ponds where they don't flush every time it rains. That's not a good thing, really. And so area, a lot of people don't do a good job of predicting this, and they build a pond that's bigger than the area they have to feed it, and then their pond never fills up except in rare years. Anyway, that area of the watershed affects it. Soils, obviously, is a huge impact on water quality. What is that soil? What's it made out of? Is it acidic soil already? Is it an alkaline soil? All that makes a tremendous difference to the water quality. Vegetation in the watershed makes a difference, as well as vegetation in the pond. What happens in the area? Is there a chance of pollution? In East Texas, with the acidic condition of our waters and soils and the burning of coal, we do have some mercury contamination in places, and some acidic rain. So that does happen. What type of fish and other wildlife are coming to the pond? Cattle, for example, maybe not wildlife, but anyway, mammals. And what do you do to manage the pond? All of this affects water quality, and water quality is not a set thing. It changes. It varies over time. Of course, this is a map of Texas with rainfall areas, and of course we're sitting out here today in this 42 to 46, 46 to 50 area of average annual rainfall. Of course, last year would have 20, maybe, so it's average. But anyway, obviously, we have to manage ponds out here different than we manage ponds in East Texas, because the water quality is different, and the amount of rainfall that the ponds get are different, and all that sort of thing. So again, how we look at water quality varies with where you are and rainfall and soil types. So, but one of the things that, again, we've said is watershed is really important, and everybody should know what a watershed is already. It's the area that rain falls that drains into the pond. And in general terms, it's different. Parts of East Texas, 4 acres of watershed will fill a 1 acre pond. You get out to West Texas and 50 acres of watershed won't fill a 1 acre pond. So again, it varies. But you need to know how large that watershed is. It depends again on vegetation. Is it wooded? Even the kinds of trees. Obviously, pine trees put out pine needles, and those pine needles have an acidic nature. They break down and release tannic acid, and that affects it. Grass or turf areas are usually pretty good around ponds. It's not always the perfect thing, but you got to ask what chemicals are used on them. What kind of soil is there? And if it's cropland that feeds into the pond, what chemicals are used in cropland? That can make a difference. And I always recommend people try to put a buffer zone around their pond. Try to stay, 50 or 100 feet away from the pond all the way around in the watershed at least with any agricultural activities. Try to reduce the inflow of unwanted fertilizer, unwanted chemicals and all that with a buffer zone. Anyway, here's what often happens. This is over in Montgomery County, and this is his property line in purple. And he comes out here and he builds him a real nice pond, and he's ready to go. And then he discovers he's got real bad water quality because of what his neighbor over here is doing, because he doesn't control his watershed. This is his watershed in green. And so he controls part of his watershed, but he doesn't control all of it. So what his neighbor does up here affects his pond. That's something else that needs to be considered. This guy puts in a heavy cattle operation and puts in a place where he feeds the cattle right in here, and it may really impact that pond. So you got to know what your watershed is, how big it is, what's in it. Vegetation really affects water quality. This is giant salvinia. How many people have heard of giant salvinia? Good. Here's oxygen under a giant salvinia mat. We'll talk about this more later, but it takes about 3 parts per million, and that's a decimal point right there, about 3 parts per million to keep fish at least reasonably healthy. It takes more than that to keep them really healthy. But they can stay alive at 3 parts per million. What is that reading? 0.14 parts per million. That's 14 100ths of 1 part per million. Is anything alive under there? I don't think so. Literally, you get these floating mats, and I don't care if it's giant salvinia, which is what this is, or if it's duckweed, or if it's watermill, or if it's mosquito fern, or if it's hyacinth, or if it's water hyacinth, or if it's water lettuce. You smother that pond. If you surface cover it, it dies. The trouble with giant salvinia is it can do that in about a month. Okay? So again, vegetation, and this is a severe example, I suppose, but vegetation can affect water quality. All right. Muddiness can affect water quality, and nobody wants a muddy pond usually. So what are the causes of muddiness when it comes to these ponds? Well, sometimes it's runoff. So does it muddy up after a rain event and then try to clear later on? If that's the case, it's a watershed problem. And the thing to do is work on your watershed, find those areas that don't have vegetated cover, and try to establish turf or something that will start stopping that erosion into the pond. Sometimes it's a pond problem, you know. Sometimes it's a livestock problem. Sometimes it's undesirable fish. Okay? Usually new ponds are always muddy. Why? Well, we've gone in there and disturbed everything. And we've disturbed soil in and around the pond. This is not a good idea, but because what's going to happen now when it rains?
Run back in the pond.
It's going to run back in the pond. The biggest thing is try to establish good ground cover, turf, or whatever in the watershed. That's the first priority. Then, like I said, I like a buffer around these ponds. And the size of the buffer, to some extent, is going to depend on the slope going to the pond. The more slope, the bigger buffer you need, and also activities around the pond. And you can, you know, when you first build a pond, you can do physical barriers just like they do out on the highway and everything. You know, you can put up these things to stop some silt for a while until you try to establish turf. You know, don't hesitate to do stuff to try to keep that soil back out. One of the big problems, though, in a lot of ponds is that we let livestock into them. You know, you think the livestock are affecting the muddiness of that pond? Duh. You know, nothing wrong with doing that. Fence them back away from the pond. You still got plenty of grass for your livestock. You got a much better pond. In fact, this is from the Noble Foundation. I work with Mike Potter quite a bit down there at the bottom. But this is a way to do it. Fence the pond off, a minimum of 12 feet. Fence the dam and everything. You've got to keep livestock off the dam. And then if you need a place to water and you don't have a water trough somewhere else, you fence down into the pond an area that they can get into. Okay? The little terrace is a little berm here. That's to stop some of the erosion that would just come down here, just to try to deflect it a little bit. And you put 1 to 2 inch gravel down here in the bottom. Now your cattle or your livestock, whatever kind you got, come down here, they may wade in there and get a drink, but they don't loaf in the pond because the gravel hurts their hooves. They get their drink, they get up, and they get out. Now you've watered your livestock, you have a much, much, much better pond.
You keep feral hogs out.
Well, that's another issue. Feral hogs, you just got to trap and shoot. Yeah, that is a big problem sometimes. Again, buffalo or some of your other carp species, common carp, can tend to muddy ponds. Mudcats, bullheads, whatever you want to call them, can muddy ponds. Even a pond with too many just channel catfish in it. If it's a catfish only pond, they can stir it up and keep it muddy sometimes. So those are all causes. So what do you do? Well, here are the 3 most common things we do, starting with agricultural limestone. Especially here in East Texas where you're in acidic soil conditions anyway, you need to lime your pond. Okay, if you've limed your flower bed, if you've limed your fields, you need to lime your pond. But again, those water tests or mud tests that you can send in and have done will tell that for sure. But most of East Texas, most areas east of I-45 need to be lined. There are exceptions to it. We usually start with 2 tons to the acre, go up from there. We were just talking last night about some pond that they put 3 tons per acre or something. It wasn't enough. You know, the most I've ever had to recommend for a pond after we tried it was we got to 10 tons to the acre. We finally got there. And 10 tons to the acre, everybody said, well, didn't you fill up the pond? No, this is ground up rock. It's heavy. 10 tons isn't that big a pile. Okay, so no, you're not filling up your pond with limestone. And that's all ag lime is. It's just limestone rock that's been pulverized. It's ground up limestone rock. So again, in about 50% of the cases that I've worked with over 30 years, if you've got a muddy pond and it's not some fish that's keeping it stirred up or cattle that's keeping it stirred up or something like that, and you lime it properly, you will settle out the mud. The mud is there because it's a charged, electrically charged particle of clay. And so what we're trying to do is counteract that charge, make that clay clump up and fall to the bottom. If you've limed your pond, or maybe you're in an area where you don't need to lime your pond and it's still muddy, then possibly gypsum or alum will work. And in my experience, gypsum clears about 70% of the ponds I've ever tried to clear with it, and alum clears about 90%, but alum's more expensive, and it's harder to find in bulk and all that stuff. So that's kind of the last straw. Don't do that automatically. But if you want to know about gypsum and alum, we have we produce educational materials, and the one that we have for shows you we've changed our name at least twice since then. But we have one, catchy title, Clearing Muddy Ponds. And it tells you how to run a little test with gypsum and alum and determine will they work? Will they settle the mud out? And once you run the test, these charts that have it, it's one page front and back, tells you about how much then you'll need per acre foot of pond water to do it. What I tell people first, if you've got a muddy pond, first thing to do is just go get you a mason jar, go out there, fill it up with pond water, take it into the barn or to the garage, set it up someplace where light can't hit it, and watch it for about 2 weeks. If it settles on its own, then it would in the pond if something wasn't continuously stirring it up. So then you worry about maybe you got too many catfish, mudcats, carp, something in there that's suspending it. In other words, it won't do any good to treat that pond and clear it if next day it starts resuspending because of fish or cattle or whatever. So that's the first thing to do. And then once you say, well, no, it's not clearing, then you start running tests like this to see if you can clear it.
Where do we get that?
All county agents have it. It's on our websites also, and I'll give you websites later on. Our websites are in the materials. But most county agents have it on several different websites. Okay, pH. pH is something that obviously everybody's heard of, everybody knows about. And again, water is very different because it's not like soil. I mean, if we test our soil this week and we say we've got a pH of 6.5, we can come back 3 months from now and test it, and it's 6.5. It doesn't matter what day or night we test it, it's 6.5, and all that stuff. Water is not that way. Water cycles. pH is not a stagnant thing. It changes on a daily cycle. And it may have a large change, or it may have a small change, and then there's some point that's about, kind of its average or what its pH is without the changing. But it is important. It affects a lot of things. Fish's ability to breathe, plants' ability to uptake nutrients, toxicity of certain chemicals. And again, one of the things you've got to worry about when you stock fish is rapid pH change. That's why we have to acclimate them or whatever when we stock them in ponds, because if we have a big 2-point pH change, could kill fish. pH cycles, again, on a daily basis, based usually on carbon dioxide. And carbon dioxide in water forms carbonic acid. So what forms carbon dioxide in water? Anything in the water that is breathing. Respiration. You're giving off carbon dioxide right now from your body Every fish in the pond is giving off carbon dioxide, and at night, even plants give off carbon dioxide. So usually it's lowest, the pH is lowest at dawn or early in the morning, highest near dusk. At the end of photosynthesis, because photosynthesis, of course, plants take up carbon dioxide. The general acceptable range is about 6 to about 9.5. Again, on pH 7 is neutral. Below 7 is acidic, above 7 is basic or alkaline. It does affect things, especially the toxicity of ammonia, which can be a problem in ponds. But you can alter it. So this is kind of a halfway normal pond. First thing in the morning, pH is going to be down here, maybe in the range close to 6. As the day goes along, it builds up because carbon dioxide being removed, and then at night, through respiration, it drops back down. I mean, it's one of these cycles of life thing, you know, the old Disney movie. Photosynthesis removes carbon dioxide in the process and releases oxygen, but only plants do that. Respiration is the other side of this cycle of life. In respiration, we use oxygen and we release carbon dioxide. And so everything does that, plant or animal, particularly plants at night. So that's why, again, this carbon dioxide builds up in the pond at night, lowers our pH because it produces carbonic acid. During the daytime, plants remove carbon dioxide and the pH goes up. So again, you know, I get people to call me and say they're in a panic. I just tested my pond and it's 8. What do I do? I don't know. Don't do anything. You know, 8's within this range. It's fine. You know, if you tested it first thing in the morning and it was 8, that would be unusual. You know. But how do we work around pH swings that are too much? And again, you did in East Texas, you can have pretty high pH swings because you have low alkalinity. So what can we do? We can alternate, or we can amend the pond water to increase alkalinity, and that buffers that pH change. Doesn't mean the pH doesn't go up and down, but it doesn't go up and down as far. Okay, it suppresses it. Optimum range for both of these things, I mean, best of all worlds, is usually between about 50 and 300 parts per million or milligrams per liter, same thing. Hardness and alkalinity. You'd like them to be closely balanced if possible. Not always possible. Below 20 parts per million, you need to line that pond. If you want to make it a better fish pond, it's absolutely necessary to line it. Because down in this range, plants don't absorb, especially algae, can't absorb the nutrients they need, the nitrogen and phosphorus properly, and so you tend to get very clear water, maybe rooted plants, but you can't get an algal bloom. So we add ag lime, especially for below 20. Try to get it at least that high. Many times we have high alkalinity but low hardness. This is usually well water, and in that case we add gypsum. And I'll talk about that a little bit. Anyway, these two again affect gill function, egg development, pH again through the interaction. So we can buffer pH by lining. Okay, so here's some of these things I get all the time. Okay, but look at it. Let's look at pH. pH is 7.8. Well, that's great. Hardness, we'll use the bottom two numbers. 165, alkalinity 160. They're almost balanced. That's beautiful. Way above 50. You know, this is good water. Somebody call me and say, what do I do? I say, absolutely nothing. You are blessed with good water. Okay? Little bit of salt, but not much. You know, it's got to be up there in the thousands before you worry about the salt line. Okay? Okay, let's look at this well. Now, this is East Texas. This is East Texas. This is pond out of Anderson County. Okay, again, pH, 4.5. That's not good. Hardness 12, alkalinity 6. Not good at all. What do? Lime. Is 2 tons going to be enough? No. My recommendation on this one is probably 6 to 8 tons per surface acre. What you're reacting with really in this case, when you lime a pond, it's not the water that you're really trying to react with, it's the mud. It's the mud you've got to alter. The mud alters the water. Okay? I'll show you liming in just a second. Here we go. Well water. Now this is well. Live Oak County. pH 7.8. Well, that doesn't look too bad. But then look down there. Hardness 8, alkalinity 729. Man, that pH hardly changes at all. But we got no calcium. Eggs die. What do we do in this case? Gypsum. Gypsum is calcium, magnesium, sulfate. We're not changing the alkalinity. We'll bring sulfate up. It's got some in it already, but that's not going to hurt anything. But we're adding calcium and magnesium. We'll bring this hardness number up. We see a lot of that with people that are sinking wells to fill these ponds, especially in certain of the aquifers. I think this is the Carrizo, I think. And anyway, you get into some of these aquifers, and this is the situation. This is old seawater. Look at the salt. It's 1.2 parts per, 1.5 parts per thousand. That's really at the level, you can taste it, but at the level where sometimes that much salt, sometimes it will affect certain kinds of fish spawning a little bit, but not too bad. What you get is if this is the only source of water this pond has, you're going to get in trouble eventually. Because if this doesn't flush at all, that salt is going to build up through evaporation. All right, here's how you line. Again, you've got to get it out there, spread out pretty evenly because you're trying to react with the mud. Put it on a barge and you wash it off. A bunch of these guys over in the trade show do this. So you don't have to do it yourself if you don't have the equipment. But you wash it off evenly. Again, we almost always start with at least 2 tons the acre. You cannot hurt a pond by adding lime to it. You cannot add too much lime to the pond unless you fill it up and remove all the water. And you don't have that much money, probably. All right, dissolved oxygen. This is what kills fish. The range in ponds seldom gets to 20, but it can go to 0. Actually, the range in most ponds will go from 0 to 10. Okay? That is in milligrams per liter or parts per million. Now, when you hear that something's in parts per million, what does that intuitively tell you? There's nothing there, right? I mean, a part in a million? Come on, there's nothing there. That's the amazing thing about oxygen to me is that fish are alive at all. But think about it. They got those 4 sets of very bright red gills on either side, right? There's literally 1 cell dividing the water from their blood. That's why they're so red. That's blood. And that's, that's the highest energy output or use by a fish is to actually remove oxygen from the water. That's why you got to be very careful when you handle them. You don't poke those gills because first thing happens, they bleed, right? Not much oxygen to begin with. We'd like to keep the oxygen level about at 60% of what we call saturation, and that's the point here. Oxygen dissolves in water. That's why we call it dissolved oxygen. It reaches a point where no more will dissolve. That's saturation. And that saturation is based on temperature. And saturation increases with decreasing temperature, or vice versa. It decreases with increasing temperature, which means when water's warm, our saturation is lower. We have less oxygen. So our problems are going to be coming about in the summertime when water's hot, and at night when what's happening? Respiration. Everything's using oxygen. Below 3 parts per million is stressful. And most of the oxygen in our ponds comes from photosynthesis, the plants there, like the algae, or a little bit from wind or wave action. And of course, we can use aeration, mechanical aeration, to increase this section. And that's why over here again in the trade show, there's lots of different aerators and stuff to see. This is the saturation curve. At 40 degrees, about a little over 12, almost 13 parts of oxygen, 13 parts per million oxygen will dissolve. That's saturation. But look in the summer. We're up here at 90-degree water temperature. 7 parts per million is all that will dissolve. What did we say? We go from to 3, fish start to stress. We got a buffer of 4 parts per million. That's all we got to keep things healthy and alive. Again, that's why artificial aeration will help your pond if you can afford to do it. Again, oxygen cycles on a daily basis, just like we talked about before with respiration and photosynthesis, because the sun comes up, photosynthesis kicks in, the plants make oxygen for you, it goes up, again it may peak above saturation slightly, nightfall hits, 6 p.m., whatever, and all night long everything uses that oxygen, the oxygen level falls, so the critical point is where is it going to be at 6 in the morning? If it's below 3, we're probably in trouble. If it's below 2, we're going to have a fish kill. So green water helps us, but too green or too much plant life is what usually complicates our dissolved oxygen cycle and can lead to low dissolved oxygen and a fish kill. So these are the problems. Too much biomass, too many fish or plants. Usually the fish side is only like in catfish only ponds where somebody's feeding a lot, not in bass ponds. Overfeeding, again, over-fertilization can cause these problems. One of the biggest problems are plant die-offs. And this doesn't matter whether it's algae plants that die or rooted plants that die. And the biggest opportunity to do that to your pond is to treat your weeds with a herbicide and do it wrong. We'll talk about this afternoon, but you can have tremendous biomass of weeds, and you kill them all at once, and the decomposition of those weeds will take the oxygen down. It's that simple. Hot weather, no wind, overcast, that can cause drops in oxygen because the plants can't photosynthesize enough to build the oxygen level back up. So you get what I call the dog days of summer here in August when it's, it's 100 degrees, it's just thick cloud cover, but we're not getting any rain, and there's just no movement of air at all, and you're just dying when you go outside. 2-3 days of like that in a row, and basically the photosynthesis can't hold that up, and it gets lower and lower, and that third morning, you walk out there and everything's dead. Again, mechanical aeration will save you from that. Then we have what's really called a turnover. Well, I'm not going to get this one. If you have a catfish pond and they start doing something like that, you probably have too many. And when you have too many, that's what's going to happen to you. Okay? It can happen in bass ponds too. The catfish ponds are notorious for that because people overstock, they overfeed, they become pets, and they don't harvest them. Okay? When you start seeing these algal scums, you probably have too much algae, or the algae is getting ready to die. Okay? And in these cases, again, mechanical aeration is all you've got to hope that you can do. When you get a problem where 70% of your pond is covered with dense rooted vegetation, it's the same thing, especially in the heat of the summer when we don't get enough cloud cover, when we get too much cloud cover and not enough wind. I'm going to move along because I'm running out of time. Mechanical aeration can save you in these cases. And again, over here in the trade show, there's lots of different types. But again, and you can buy a fountain. If you want it to look pretty, buy a fountain. But fountains are not the most efficient aerators. Okay? These kind of aerators are very efficient. The physics of this is if you can break water up into small droplets and you can basically hang it in the air for about 36 inches, it will absorb all the oxygen it's going to absorb from the air. So throwing it up 20 feet, real pretty, but you wasted 18 and a half. You used a lot of energy to throw that water up in the air and it wasn't efficient. Doesn't mean you can't have a fountain. I'm not saying that. I'm saying it's not efficient. These are very efficient surface aerators, but you still have to base it on how much aeration you need. If this is only throwing it about 18 inches up, it's really foaming the water, really frothing. Okay, and those are great if you have electricity. In the aquaculture, fish farming industry, and again, if you had a big, huge pond, you might want to go to something like this. These are the most efficient aerators made today, based on science and testing and research and all that stuff. It's a paddle wheel. This thing is 10 horsepower, runs on 3-phase electricity. Not many people have that to their pond. Okay? But some people do. And if you want an insurance policy, you got a 30-acre pond or something, there it is. Okay? You got a big pond, you don't have that kind of electricity, you don't have that kind of money, you've got a welding capacity and a tractor, you can build a PTO aerator that will keep your fish alive if you see that they're stressed in time to get it out there. Because again, if you show up at noon, they're already dead. You show up at 10 o'clock in the morning, half of them are dead and the rest of them you can't save. You show up at 5 in the morning and see them up at the surface piping, you can go get this and back it in the pond, you may save them. Water pumps work for small ponds. Don't shoot it up in the air, shoot it across. You want to create waves. Don't put this down in the bottom of your pond, put it in the upper foot. You really want to have fun? Back your bush hog in. Here's the question, which is more important? Replacing the bushings on that shredder or saving your fish? Because this will burn those bushings out, I guarantee you. But it will put a lot of oxygen in that water if those blades are just slapping it. Everybody laughs at that one. I don't know why. Ponds stratify in the summertime. We all know this. We dive down and the water down below is cool. Usually here in Texas they stratify somewhere between 8 and 12 feet. All the fish are in that upper water. Why? Because this is the oxygen is this dotted line. You go down, you hit that thermocline, the oxygen goes to almost nothing. Okay? And so we all have that misperception sometimes that cold water must be good, fish must like air conditioning. Well, why? They're a cold-blooded animal. They don't like air conditioning. They want to be warm. But what makes it even worse is there's no oxygen down there for them. They're not in that cold water. They may be in the thermocline, but they're not down there in that cold water. So this is limiting the area for fish, limiting the area for food production, limiting lots of things, and it can produce some pretty nasty toxic chemicals. So if you've got a deep pond and you've got electricity, let's destratify it. Destratification is something I've worked on for 30 years, and I've never had anybody put it in that didn't come back and thank me. Breaks down that temperature and chemical stratification, particularly in ponds that are much deeper than about 6 feet. Lets the whole area of the pond be productive, gets rid of that unproductive thing, and it stops turnovers and it decreases that amount of habitat. Here's a couple of them that are, both these guys are in the trade show. It's a diaphragm or piston pump up on the shore, tubing that runs down into the pond, and then some kind of diffuser system down here in the deep part of the pond. It may take more than one of these. If you've got a 30-acre pond, one of these isn't enough. So depending on the size of your pond, these guys can help you with this. And at the surface, that's all you see. So it is adding some oxygen to the pond. They're not the best aerator. They're a good circulator destratifier. They do help you with oxygen. You still can potentially have an oxygen depletion, but the potential is dropped by about 95%. Here's something that I am not supposed to do. A lot of people want to know, how do I test oxygen? How can I know? Well, if you want to go out and spend $800 to $1,000, you can buy that little meter that I showed you in that one slide. Nobody's going to do that. Well, some people do. That's true. But for $50, here's what you can buy, and it's the only company I know that makes it. It's called Chemetrics, and this is their little oxygen test. You get 50 tests and a little color chart for $50. And then the next time you can buy 50 tests for $25, I think. So it costs you about 50 cents a test. And all you do is, it's a little vial, it's hard to see those. It looks like a eyedropper. And you basically stick that down in the water, break the tip of it off. It's a vacuum, it sucks the water up, mixes it with the chemical, and depending on how blue it is, tells you how much oxygen is there. So it's not something you'd want to do all the time, but in the heat of the summer, cloudy, no wind days, it'd be worth your time to go out there and see what your oxygen is, especially early in the morning, or if you think you might be having a problem. Toxic organisms exist. One of the biggest ones that we're seeing problems with here in Texas now is golden algae. There was a handout for that if you got it out there. There are some amoebas that you hear about to get up people's nose and kill them. Don't snort mud. There are bacteria. That's what golden algae looks like. That's why it got its name. That's what it does. Kills everything very quickly. If you get it, it's a wintertime, mostly cold water phenomenon, and especially, it likes a little salt. You really want to scare yourself about algae, read this publication. But the reality is, most of these things are very, very rare. But the other reality is, often when they're most problematic is droughts. So we had a lot of fish killed last year. Not just from no water, that kills them, but from other things. E. coli, everybody worries about that. Well, guess what? You have E. coli in your pond because somewhere around your pond you have mammals and birds, and they excrete E. coli. So don't drink pond water.